Se escucha. Perdón. Bueno, bienvenidos. Mi nombre es Luciano.
Good morning. My name is Luciano, and together with Sabrina, we'd like to share with you a prototype we are working on. And the idea is to work on cognitive computing, which we are integrating in GeneXus, and exchanging information with Watson. And our idea is to solve technical matters in the best way possible using these technologies. Our talk is going to be developed as follows. The first one has to do with a problem, then the project, then we're going to be referring to the prototype, to the cognitive prototype, exploring ideas. These are the first iterations. We've got our preliminary results we would like to share with you, and then we'll draw some conclusions and some tips that we'd like to share. To kick off then, we would like to start with this statement. 90% of the world's data has been generated over the past 2 years. This shows the explosion of information, which is a growing trend. This isn't going to change. Now, we are not away from this. We're not alien from it. And software developers, we have to manage this and handle this information to tap it whenever we need it and wherever we need it. The symbol of infinite there on the screen shows how many business areas interact outside the company and the community as a whole, so that GeneXus can evolve on a daily basis. Since the beginning of an idea, somebody had an idea that's published somewhere, a specification, a very detailed document is written. There is a prototype that is generated, and if it is decided that we will continue, then we will say when it's going to be integrated to GeneXus. That goes into the building. There are teams from different areas, as it happens in any ecosystem, collaborating as cells to improve those features to appear in a GeneXus version. Once the information is available, it can be exploited so that GeneXus developers can use them in the best possible way. Then the feedback is important. Is it well used? Are there any possibilities for improvement? It's a continuous cycle. This provides very enriching information about how it's used, the scenarios where we can use it, and that is dispersed in many information sources. It doesn't matter whether these data are structured or unstructured, or locally or in the cloud. Now, where are we there? We've got GeneXus Search, which is a very powerful search engine. Along the time, we've integrated different data sources. That's what you see on the left of the screen. All the GeneXus community has quick access to information. Now, this tool is based on keywords. To find information, I need the detail of how the tool works to get the utmost advantage. So it may happen that I don't find the information, or I find lots of details that I've got to start looking for to get what I really want. This is a search then on keyword basis. I would like to do it on a more natural language, and that is how automatic assistants have developed a lot in the past few years. We've got assistants in our PCs, in our cell phones at home, providing us with useful information within the context they are used. So why not build an assistant that can be easily consulted in natural language for GeneXus? Now, this is an enormous project, but let us contextualize in a minimum feasible product. What we want is a customer care assistant. Why? Because that's the strongest contact point with our customers, with our clients, with those who are using the tool, and we'd like to have feedback and we want to be effective there. That's fundamental. So within the framework where we are working, we're trying to help this area out to make it grow and become more effective to obtain the information that our customers are asking for. That doesn't mean that in the future it can be made public for everyone to use. Well, as regards assistance, then we would like to change the interaction with the final user, thinking that why don't we use a chatbot? When I ask a question in natural language, that chatbot, it's intelligent and can ask me for more information to contextualize my question better. And at a second stage, it can make a search in an inference engine that is more intelligent, that can make more interesting semantic inferences so that the result is more adjusted to what I need. At technology level, GeneXus 16 includes several components. Damian mentioned the AI GeneXus model, and we have the possibility of developing conversational dialogue so that users feel at ease, and as it happens with any chatbot. Then we have an open API. This has been in place since version 15, and I can import any service in the world exposed as JSON. Now, why are we using Watson for prototypes? That's a very important component, very strong. It understands and processes natural language, and that's where it can add a lot of value, particularly for the back end as chatbot. We want to use it as a knowledge repository where we would upload information and execute different processes. We are using Discovery and a tool that can help us to contextualize all that knowledge in GeneXus so that the tool can understand what a GeneXus object is, what a procedure is, and so that it can be used to make more accurate questions or consultations. So Sabrina will tell us about the prototype. Good morning. As you said, Luciano, our solution is based on two components, basically. That is, services provided by Watson Assistant and by Watson Discovery. There is a search engine with an additional layer of machine learning, of processing natural language, which will give us more power and will allow us to have better answers to the questions made by customers. Watson Assistant will allow us to create our own chatbot. Now, as Luciano said, we've been working on this project. Basically, it's a research project. We had a minimum feasible product, but that research was good to obtain information and present it to you. I particularly wanted to share with you the Discovery prototype. When you use these services, what you have to do is to upload your documents to IBM Cloud. There a workspace is built to store all these documents that we've uploaded. These documents are converted, are indexed, and they are ready to be found. That's the first process. Then, since we are working with machine learning, and that's the basis, we're going to make some important training to our solution. I'm going to tell you about it later on. And in view of obtaining better results, we are going to be favored by the data semantic analysis provided by this Discovery service. And again, we're going to be looking into it later on. Now, as regards the results improvements for searchers, we have to take into account that Discovery services are based on a search engine. Therefore, we have to work with that in mind, as if we were with an Elasticsearch or Solr or Lucent, what we have to do is to work on the keywords of documents as we would do for any search engine. And that's what we've done. The group of documents that we selected for these tests, we worked very strongly on improving the keywords in those documents to be able to find them easily. And in fact, we improved Wiki so that when the documents were being edited, we could include keywords. Once that basic work was done, we can move a step forward and go one step up on our ladder and start working on training. That's what this type of service allows us, because it's based on artificial intelligence. Now, what's training, or what does training, why would it be useful? Well, because documents that answer a question the best will have a better results ranking, will be ranking first in the search results, and that's what we want to do. Now, to do that, we have set up a training data. A training data is a group of questions. These questions must be representative and frequent queries that our system will receive. Now, given that group of questions, then we'll look for the documents answering those questions, and they're called examples. For each one of those examples, we establish a score. It's called relevance score. It's the level of right answers from that document in relation to the query. So as a result, we'll get the documents answering the questions best will be ranking at the top of the list. Now, recruiting questions is an important work. We have to establish a strategy to do so. It could be by reading them from the system. It could be putting in the system in an environment, in a pilot environment. But to get the most frequent questions to our system, to have a group of training data. Another important point is that since we're standing on LPL, we needn't be comprehensive in asking a question, because any questions that are semantically equivalent to a question, to a given question, will return the same results. Now, training is ongoing. This changes the paradigm of traditional apps where we develop an app, we test it, we put it to QA and production. But in this type of apps, training is one stage further, and it's ongoing. In fact, if there is no good training, perhaps the application isn't useful. And that's why it's fundamental to take all that into account. It's one further process. Now, as I said, we are working on keywords because any search engine takes into account keywords to look for results. And they've got their algorithms, the weight of keywords, the times the keywords appear on the document, and so on. But we want to go beyond that, and we want to move on to concepts. We don't want to obtain results from documents on the basis of keywords, but on the basis of concepts, of semantics, of the meaning of the document. Many times, a question asked by a user hasn't got the necessary words to get the best results, the best documents as a result. But if the meaning or the semantics of that query does have the necessary information to obtain the expected result, that'll be our target. And this is what I'm going to be telling you about now. Here, we started working with data enrichment and entity extraction. Now, in our documents, we manage a technical language, an IT language. but it's a language that is biased to our reality, to GeneXus. It's very specific. Now, this is just a part of the document. In green, it says data provider, procedure. Those are concepts. Those are GeneXus objects. Now, a grid is a control. Load is an event. Start is also a GeneXus event. Smart devices, depending on the context, could even refer to a generator. So the fact that we can go from unstructured data to classification and get to structured data that are classified is what we call entity extraction. And that's what we want to do to enrich our data, and so that the tool can make a semantic analysis of the data. Now, the tool that we are using, Discovery, provides in a predetermined manner an extraction of patterns or entities, but they are generic as our reality. Since our reality is very specific in terms of language, that entity structure that is predetermined isn't useful. And that's why, as Luciano said, we are using a tool also from IBM called Knowledge Studio. It allows us to teach our concept, our reality, our language in particular. Now, this tool selects a group of documents that is representative. It's quite similar to what you see on the left-hand side of your screen. We take the document, we give names to things, and we say, well, a data provider is an object, a procedure is an object, a grid is a control, start is an event, and so on, in a representative group of documents. We are teaching the tool the concepts that we deal with. Now, once we have taught it with a certain training data, that's the way we call it, it's a certain determined group of documents, that information is trained. We train it in Knowledge Studio. The model is uploaded to Discovery. That's where we've got all our documents. Now, what's going to happen in Discovery is that that knowledge that we have uploaded will be extrapolated to all the documents that we've got in that workspace. This means that as from now, knowledge that we've got in the model, in the Discovery model, allows us for the identification of documents, talking about GeneXus objects or grids or generators or whatever. That's the basis to make a semantic analysis of our documents. Let us have a specific example now. Let's suppose that users ask us a question similar to this one, which is quite simple. How can I configure GAM permissions in a GeneXus object? Now, an object has a very broad definition. Now, for us, it has a specific meaning. So what I'd like is that our solution returns the documents referring to how to configure GAM permissions, or a document talking about how to configure GAM permissions in a web panel. That is, that the documents containing the documents that or the information that the user has asked for is returned. So the question we're going to ask Discovery, that's our searcher, is not only a query in natural language posed by the user, but it will include filters. Now, what are filters? Well, filters are like hints. It's like a help given to the search engine where the meaning of the semantics of that question is to be found. In this case, the question that we were seeing plus a filter. Now, the filter is written in Discovery using Discovery syntax, and what I'm going to do here is to include the documents with this concept because that's what I'm interested in. Now, out of all this, we can infer that I must know the meaning of the question because I've already put in semantics, but I have to extract the meaning of the question that the user is making. And that's where we have another large component that we have called Watson Assistant. We're going to have the chatbot, that's the interface with the user, and we're going to extract the meaning of the query. But I'd like to say something here in brackets. Why have we decided to use a chatbot? Why build a chatbot as an interface for our solution? Well, first of all, because of the user experience it provides. It's absolutely different if you are going to ask a query in a search bar than if you do it in chatbot, where someone can be more verbalize it better. Now, last but not least, is that if the initial question is ambiguous, it can be made unambiguous, asking more questions and say, well, what GeneXus version are you using? What's the upgrade, Android version, Java, until you get a specific question or query that you can send up to discovery. Now, the context. Well, when we talk about semantic searches, it's fundamental to have a context about which you're talking. And the connection point with what we've just said is the difference of entities. That is, to know what the user is talking about, to be able to extract from the user's question, to understand the meaning of the user's question, and to send that result as filters to discovery. Now, to explain a little bit further about how I know what the user is talking about, well, now I've got the component of Watson Assistant with which I'm working. I have defined entities in Watson Assistant, which is a group of values. Every value may have n synonyms. And how do you go about it? Whenever a user asks a question, it is automatically inferred or detected if at any point in time it mentions the value or the synonym of someone I have defined, of an entity I've defined in assistant. That information provided by the assistant service says, well, this is what the user has mentioned. That value is going to be sent as a filter to the searcher. Therefore, so far is behind the screen. We've been doing research, but we are GeneXus developers because we have always worked for GeneXus. And we did it with version 16. We needn't worry for programming anything manually. So what we used, GeneXus 16 and a chatbot generator. Now, the chatbot generator allows us to create a chatbot in our knowledge base. Basically, what we've defined in GeneXus is an object called conversational flow. This is the view. It's like a tree, and every flow represents an intent in assistance. In this case, it's in view of Watson Assistant. An intake is what the user would like to get as an answer. Every flow corresponds to an intent, and I'm particularly interested in telling you about the search intent. In this intent, you basically request the user to make a specific question, the technical question. For instance, tell me what is your technical consultation. And that is in the query variable. The rest of the information that you can see in this node is not requested explicitly to the user, but it's inferred if it's mentioned. It is inferred from his original consultation. Out of his initial consultation, it is inferred whether there is any value by the entity defined in assistant. On the basis of that information, we move on to discovery. What we do is to call in a conversational object to get an answer to the query. And that object basically calls a query procedure from the discovery module, which receives the necessary parameters, and particularly the parameters of the consultation in natural language and the filters. So we call in discovery and conclude the cycle. So what I'd like to share with you simply is that we needn't worry about programming this procedure, because since, as Luciano said, we are using the Open API tool, import tool, we are going to the REST discovery services, and we introduce the procedures to consume that API. And so we didn't have to use the, make the head and using the box and so on. The same applies to the rest of the procedures that we've used for training, to update documents in the cloud, to see the status of the training, to upload queries, and so on and so forth. So I'm going to give the floor back to Luciano so that he can tell you the preliminary results from our project. Thank you, Sabrina. We are doing our first iterations, but we've had some very interesting results we'd like to share with you. Here is the question in natural language is there, asked by the final user. The chatbot wants to have more context, and the question is, what GeneXus version are you using? And so that relationship, those filters are used. The discovery asks them, and then we say, give me your answer. In our particular case, the first two links where you can get the answer to the question made by the final user is here. Another example, simply note that while the consultation is a bit more detailed, it's in Spanish. In general, here we are using our internal services. Daniel said, I can detect the language, I translate it into English. An important thing is that we are working with documents in English, and that is part of what you find in the wiki. And following that, well, the final user doesn't see it. On the basis of our English version, the chatbot makes the inference, and he says, I hope this is what you need, and this is what returned. It returned. In RAM, they've been integrated with GeneXus 15. Is there an option to configure the menu and so on and so forth? The first 3 lines shows how to use GAM and the GAM levels at the more technical level of API, GAM API. So this is a good result of a query example where the semantic knowledge worked well, both at the semantic church level and the chatbot. This is a more complex example because it relates lots of information to GAM and to GeneXus.gam. And so in this case, we have to relate the chatbot. The question is, what GeneXus version have you got? These are the results. So the first links are all related. The consultation talks about multiple repositories. There are several things. That connection.gam and what the final user put in is related. This is just the beginning. These are the first iterations. We are now trying to focus on training to see what the steps to continue are, move little by little, step by step, but with a firm step. Some considerations to take into account, some conclusions to be drawn. Well, GeneXus is very ready for this type of API integration so that you can make a minimum feasible prototype to evaluate solutions. In our case, we are GeneXus plus Watson. You register and you have a light version allowing you to use all versions, all services. Now, for a minimum feasible product is more than enough. Then, since it's monetized, well, the provider that you choose will tell you about it. So this is the easiest part, that is how to integrate this is the question. As Sabrina said, This is very much used in machine learning. The machine learns from the quality of the data that you provide it with. You have to spend some time, you have to analyze data. We are doing some data science. It has to be general to the context that we've got. We've got training at different levels, at the level of the chatbot, at the level of the documents of semantics, what GeneXus objects are, in order to detect in the natural language in the what entities are there, and also at the query level. Questions that are semantically equivalent will return the same result. I may change that result so that it's better adjusted to when the question is not necessarily correct. So there are different levels I can be working on in training. And that is how in GeneXus, in our data, in our knowledge base, we've set up some monitoring activities to see what's been consulted, what the results obtained are, to know this for the future. Do we have to work for a new set of data? Do we have to have more of this or that? So every consultation that the customer care people ask gives us feedback saying, well, we haven't got an answer, this answer is better, or this, or even a context saying this question is horrible, so that in the next iteration we can improve and know where we have to focus on. So our invitation is that you use it. The power of doing is important, that you explore, and you've got everything to do so. So thank you very much.
Les dejamos unas charlas relacionadas.
You have some related talks there on the screen, and we are available for any consultation. Thank you.